Hello and welcome to Metro Home Theater Tech Tips. I'm Brent.
I'm Adam.
Welcome aboard. So what have we got today, Adam?
Well, today's another good day. We're going to be talking about, this is another part of our series of HDMI deconstruction episodes. Today we're going to be talking about HDMI EDID
Part 2.
And so the reason that we're doing this is that there's actually a lot of information with EDID. And
your attention. Please be sure you are washing your hands before entering your department while maintaining your social distance from one another.
Thank you.
I think we need to resync our clock.
We may need to.
We're 2 minutes early.
So anyways, yeah, so last week we did an episode on EDID and we talked about the different functionalities for what it did, how it worked. This episode we're going to get into deeper detail about how it works, how to fix it. And also,
that's the important part.
Yeah, and also what is the future of EDID and what we're looking at for HDMI 2.1. There was just so much information that we couldn't cram it all into one episode, so we decided to go ahead and break it up a little bit and have 2 different episodes for EDID on its own. So
okay, then I have a question for you.
Yeah.
Who is this week's sponsor?
We're sponsored by the letter A.
A?
Yeah.
Alpha?
Yep.
And what does A stand for?
It stands for the HDMI 2. This is a reoccurring sponsor of ours because it's a great product. This is the all-in-one tool that has all of our HDMI correction tools built directly into it, except for, of course, the GA series products,
right, for
which is
distance for video.
Yep. But all the EDID fixes, all of the current fixes, all of the hot plug fixes, all
the
of
voltage,
the voltage, anything that we have
delay,
in there. Yep.
Everything's there.
Yep, it's all built directly into the AIO2. So great product. Talk to your rep, talk to your distributor, find out about pricing and availability for you. It's a great product. And if you run into an issue where you think you might need that, or if you run into an issue with HDMI in general, give us a call. As always, you can contact me here in the tech support team at 386-492-8584. You can also contact Brent at 866-839-9187, extension 2203. Brent, when can they contact you?
They can contact me from 8 in the morning till 10 p.m. at night, 7 days a week. Now, it is important to know that Adam and I are not sales.
Yep.
If you call about how much is something and where is it and how soon can I get it, we offer no value. However, if you do want to know how to fix something, we are the guys.
Yes. So, as always, everybody, thank you for checking in with us today. If you have questions for what we're talking about today, please leave it down in the chat section below. If you are checking in with us and have a question about something entirely different, if you want to talk about networking, if you want to talk about power, if you want to talk about surveillance, if you want to talk about
Tuesday,
I guess, yeah, what happened yesterday for you on the job, let us know down in the chat. If you are catching this after the fact and we have already recorded this, leave those comments, questions, and concerns down in the comment section below. And as always, a like and a subscribe is very helpful, and hit that little bell notification to let you know whenever we go live or release a new video, which we did release a couple nice new videos recently.
by the way, yours on the Control 4 piece was fantastic for interfacing the AIO to the Control 4.
That.
I give all the credit to the art and video editors.
Yes, I do too, because they're honestly they're great guys.
But it came out great.
It did. But also, of course, we do go live every week on Wednesday at 3 p.m. Eastern time. So you can always check in with us every week on that. Or, of course, if you need to catch it after the fact, it'll be recorded and put up on YouTube. So,
before we get deep into the questions and the data, what are we up to for subscribers now?
We are actually up to 943. Subscribers. So we are like 57 subscribers away from 1,000.
Come on, guys.
We're looking for that.
Send your dollars, send your dimes, and send us cards, flowers, and candy.
If nothing else, it doesn't do us really any good. It does inflate my ego a little bit to let me know that, hey, we made it to 1,000 subscribers. We're somebody. Maybe we'll get there, but we'll see. So
is that what it's going to take for you to be somebody?
Yeah.
Okay.
Yeah. For this, it is, yes. Okay, guys, so we're going to get into talking about EDID today. We're also going to be talking about some of our calls that we've had in the past week and some interesting ones that we had to deal with that as well. And we're going to try and get in some kind of little news snippet for what's happening in the industry in total. So stick around to the end for all of that.
Actually, the news snippet's really awesome.
Do you?
I want to do this first.
Okay.
There is finally a CTS released yesterday for HDMI 2.1 cables.
Really?
Yesterday.
Okay.
And that would be Tuesday the 31st?
No, the 1st.
The 1st.
Tuesday the 1st.
Thursday the 1st. So it's only 2.5 years late.
Oh, well, yeah.
I guess better late than never.
So this is actually really big news. This is a surprise to me as well because I had absolutely no clue that happened, which is kind of interesting.
Why would I tell you?
Well, I know, but just the fact that they flew that in under the radar so much.
Well, and they did because my guess is because there's been so much hoopla. about it not being there, but secondly, it really only covers short passive cables.
Gotcha.
So it's not really a complete
Right.
CTS, but it at least is something so that you're going to be able to properly test a cable for up to probably 3 meters
Gotcha.
for the HDMI 2.1 specification.
Cool. So there you have it. That's our news article for the day. It's a really close to home news article for us because it's HDMI. So that's wonderful. That's
Actually very
exciting.
nice because I did not predict it till next year.
Yeah. So there you have it. So Brent, with that, let's dive into EDID, and it seems like you're kind of wanting to take the reins on this one.
Well, this one's something I've been dealing with since day one.
Sure.
And EDID is the most important part, really, of HDMI. The vast majority of manufacturers focus on picture and sound. And the reality of it is, as long as you got a sparkle-free picture, you're doing the job video-wise. But before that can even start, you have to do all the negotiations. Who are you? What are you? Resolution, bitrate, color depth, firmware, feature sets, HDR, Dolby Vision, HDR Plus, audio, Atmos. All these things have to be negotiated prior to the release of picture and sound. The picture and the sound, with the exception of distance, is actually the easy part because it's very defined within the specifications.
Right.
What is not very defined is EDID because that's not actually part of the HDMI specification.
But it's used by EDID. Or
Yeah,
by
HDMI. They
pardon me.
reference you to the Philips I2C spec, I2C spec.
Huh.
That's not, so EDID is not part of the HDMI shell.
It's just used by HDMI.
Right, they just say, see this,
Yeah.
and good luck.
Well, that's kind of frustrating.
Where the TMDS is part of the spec, and as we move forward into HDMI 2.1, when it completely changes, and that's episode 5 or 6.
Yep.
It's a whole new world. So let's talk about what's happening with EDID and why you guys see failures. First off, we touched on this briefly last week, but let's talk the basic failures. And we've been seeing this since day one of HDMI. Typically, what you will see is a loss of audio is number one. Number two will be mode out of range, frequency out of range, frequency not supported, and last but not least, no HDCP. Switch to component.
Right.
I love that one.
Yeah, that's
Particularly in
that's a nice
devices
one,
that
right?
have no component jack.
Yeah. Well, cable boxes.
DirecTV.
Yeah, DirecTV cable boxes. Well, yeah, I mean, the DirecTV does have that little pigtail that the
Not on all of
9-pin.
them anymore.
Yeah, I know. They're starting to remove it from all those. So
Now, officially, the analog sunset was December 31st, 2011, January 1, 2012, was the, in theory, no more analog. Do you
Right.
know why there was an analog sunset?
as far as I know, it's because of the HDCP or the what's the term I'm looking for? In order to stop people from
Copying?
yeah, copyright protection and not
And
copyright
that's a
protection,
wonderful
but-
theory.
Yeah.
It was all about this,
Well,
money.
of course. Yeah.
Because when you take an analog section out of a product, you cut a tremendous amount of cost.
Right.
You got circuit boards, you got connectors, you have technologies. All of that is fixed finite cost. And at that point in time, you could buy a Blu-ray player, or DVD player anyway, for $49.
Yep.
If you've got $8.50 and hard BOM, building material cost, that's a lot of money that just went away. That's a fifth, a quarter of your cost.
Yeah, exactly.
Just by ditching the analog connections. So EDID became very important then because there was not a fallback to component, S-video, or composite. So I'm going to push you to the side
Okay.
a little bit so we maintain our social distancing.
You see how
ask
he's just kind of pushing me around out here, guys? You see how this happens?
Yeah, it doesn't happen often, but if you would give me an overhead, young man.
Sure will. And 1,
2,
2,
3.
and nope, we're gonna go now. There you go.
Okay, so this is basic high, low, and clock. Now the clock is very critical for what happens in EDID because the clock determines is something high or low in a given time frame. Now it's real simple. Let's say this is a doorway. All this is a door to your house. When you open the door all the way, it's a 1. When you close the door all the way, it's a 0. Anything in the middle is of no value. It's not big enough for you to get through, but it's not closed enough to stop something from getting through. So this clock is very, very important. And all we really want to know, is the data high or is the data low? That's it. Anything in between is ignored by the system. Now, as we discussed last week, the system is digital, but it isn't. It is only read in a high and low state. It's still an analog waveform. So you have a waveform that still looks like this. And it's just like every other waveform out there. It's only read here and here. So in order to keep it simple, the clock became very critical. The thing that you have to know about a clock is the data in position, high or low, when the clock ticks? Now this is done in nanoseconds. I'm going to clean off the board real quick here. Now, anybody that does lighting programming, whether it's Control4, Crestron, Lutron, Light Touch, Central Light, whatever you've done through the years, you are familiar with a rise time or ramp time. The ramp time is how long you tell the system to go from off to on or from on to off. It is the exact same. Can you move me to the far corner?
I might be able to.
It is the exact same thing with EDID. You have to have a very prescribed rise time for the data to be in position. As you can see, he's moving me over now. This is measured in nanoseconds. Now, the specification for HDMI is from 350, wow, to about 1,000. Now, most devices actually will go up to about 1,300. And they do this because they assume it's going to be terrible down in the lower regions. However, the faster it is, the better off you are. And this is where EDID repair tools like our Junior, the AIO, the GA2, the GA1, the DAD, the Super DAD, and our original wall plates helped you. And a lot of our active cables that had it built in.
Yep.
Because they will strip capacitive loading. Now, in engineering parlance, a capacitance lags, meaning capacitive loading on a data bus is like throwing weight into your knapsack. You start to move slower and it gets heavier and you can't move as quick. Inductance leads, meaning you're now taking weight out of your knapsack. In fact, you're filling it with helium. So you're going to be floating along with your feet, just barely touching the ground. Capacitance loading is what we fight on a day-to-day basis. And you get this from a variety of areas. It can come from poor circuit board design, cable boxes. It can come from poor cable design. I won't pick on any websites. It can come from cold solder joints. It can come from multiple devices plugged in line. Now, typically what will happen is it's not a single thing that causes the collapse. It's a cumulative effect. So you'll have a little bit of capacitance added maybe in the terminal design. You'll have a little bit of capacitance added maybe in the circuit board design. Not a single one of those devices is out of spec, but added up all together, the cumulative effect is out of spec. So what you will see is this. You plug the system in, you turn it on, everything works beautifully. You go away, your boss gets paid, you're happy, you're off doing another job. A week, 2 weeks, 3 weeks, a month later, the boss calls you and says, hey, the job that you did is having problems. Can you go take a look? Sure. You drive over there and you got mode out of range, frequency out of range, HDCP not supported, or audio dropouts. What do? Everything's plugged in, there's no settings to adjust, because you've already done what we told you, which is turn off CEC, set a single resolution, and keep it simple. So you've done all those things ahead of time.
I think all of next episode's going to be basically turn off CEC.
Yeah.
So, but we'll
turn
get
off
there with
CEC,
that.
turn off CEC, turn off CEC.
Brent, should I turn off CEC?
Always turn off CEC.
There you go.
Hey, Adam.
Yep.
Turn off CEC.
Thanks, Brent.
So, you look at this, what do? Well, typically you're going to unplug the cable, plug it back in, you're just rebooting it. And it works. You go away and the problem happens again. The problem is happening because of capacitive loading is building up over time. So your data is no longer getting a good rise time. Your data is now getting slower and slower. And it's no longer in the area where the clock can read it. When this happens, the system fails. The best thing you can do ahead of time is put in one of our JR3 boxes
Got this right here.
on your jobs ahead of time. Now the JR3 is a capacitive stripping tool. Its entire job is to remove capacitive loading from the data bus. This has been without question the most popular tool we have ever sold. Now this is the 5th iteration of this piece, I think. Going all the way back to our original black box. Guys have sworn by this thing for years because it fixes the problem. And it does it simply by stripping all the capacitive loading off the data bus and returning you to a proper rise time. Now, let's assume your rise time is correct. What do you look at then? And if you've got the tools in place, the rise time is correct.
Right.
Now we have to start looking at setup, because inside of EDID is all the master instructions. Now, we took a call this morning.
Yes, we did. Yeah.
One of the things that we see happening is enhanced and standard inside a setup. Now, when you look at a standard non-HDR system with the EDID, there are fairly static instructions in there. This all falls under the old school HDMI 1.4 chipset that we've had around for years. And as long as your capacitive loading is low, it's going to work. But now let's say we want to throw HDR in. Now, HDR is a whole new set of instructions that are typically, not mandatory, but typically associated with an HDMI 2.0 chipset.
Right.
Now, the 2.0 chipset and the 1.4 can't do this if it's told to for EDID.
Right. And if the content's there for
And
it.
if the content's there.
Yeah.
It will start to shift the data over to other areas on the bus. What this plain and simply means is if you have a cable box that is non-HDR, which is still 99.99% of them, and you plug it into a port that has HDR turned on, that cable box is receiving questions and responses in a language it plain and simply doesn't understand.
Right.
It's speaking English, the next device in line is speaking Mandarin.
So everybody, again, as always, thank you for watching. If you have more any questions or anything about what Brent's talking about today, please leave them down in the chat section below or off to the side. I think it's over on that side, if I believe, on my side of the screen. And also, if you have any questions or comments after the fact, you can, of course, leave those down in the comment section below. Now, here's an interesting thought process, because you were talking about HDR.
Yes.
Let's touch base on that for just a quick little bit. And you were not prepared for this, by the way. I mean, you are, but because you've dealt with it. So when you're talking about cable boxes and HDR,
Yes.
cable boxes have HDR.
No. No.
Kind of, right?
No, they can't have HLG.
HLG, that's what I'm looking for.
Hybrid log gamma.
So what's the difference?
Well, when you look at HDR, HDR is a frame by frame technician assigned lighting value.
Okay.
So what that means is when you look at HDR in a film, somebody sat down and looked at each individual frame of that movie, just like this. And they said, okay, in this frame, we want the lighting value to be this. So this is not done on the fly.
Right.
HLG is an on-the-fly HDR emulator.
Now, who controls that part of it? Or
That
what
is-
controls that part of
HLG is controlled at the live event,
it? Okay.
typically by, electronics run by the producer.
Right.
You have an engineer sitting in front of a panel, and what they will do is they will set in a static value, because you cannot adjust frame to frame live.
Right.
So what they'll do is they say, okay, we're shooting this football. Let's do a white equalization of the field. Here's what we got. Okay, I want to bring up, let's set the HLG to whatever value they select.
Right.
Now, there is metadata carrier in that. Assuming that your cable box and your DirecTV can support this, they will decode that data as HLG as live. Now, you can send an HDR movie, 4K HDR movie, over DirecTV and a select amount of cable boxes
Right.
that do support HDR.
Right. Now,
but
again,
very few.
That comes down to the cable box, the physical cable box itself,
Yes.
but also the media that's being sent to it,
Yes.
the content that's being
So
sent
if
to
you're
it.
sending the latest, greatest movie down DirecTV, pay-per-view, or and you and I both heard the name of the box a couple of times, but I honestly don't remember it. I think it's an Xfinity box.
Xfinity, and there's a couple others that do a 4K
Okay.
image as well.
So in those boxes, if they have that 2.0 chipset, meaning they can decode and handle all this stuff and output the 4K, it is going to send it down the pipe.
yeah.
Now, you're also seeing HLG on live broadcast over the air.
Yep.
On cable boxes and DirecTV. Now, it's still HDR. It's not quite as HDR-ish
Right.
as HDR, HDR Plus, or Dolby Vision, but you do get the enhanced effect of it.
So who decodes the HLG? Is it the cable box itself, or is it the display?
No, it will be the display,
Okay.
but the cable box has to handle it to move it along.
Gotcha.
The extender has to handle it to move it along.
Yes.
The AVR has to handle it to move it along. It is an additional metadata data stream. You know, everybody thinks it's just ones and zeros. You know, it's 10110011. That's all well and good.
That's a bad word, Brent.
I believe you. However, it's not a single stream. Now we have an additional stream. And that additional stream has to be carried on an additional, it's multiplexed over the other data.
Right.
So if the devices cannot recognize this stream, it's not going to go anywhere. The inverse is absolutely true as well. So if you have a cable box that is not capable of supporting HDR or HLG,
Right.
but it's getting data back that says, hey, let's do this, it's in a language that box does not understand because it's in a different format.
Right.
So effectively, it's like you coming to work one day and it's no longer Stuart, I, and Luis. You now have a Mandarin-speaking boss that can't speak English.
Yeah. Yeah.
What are your chances of actually understanding what they want from you?
Slim to none.
Even if they point,
Yep.
what are they pointing at?
Right.
That's the problem with HDR. That's the problem with EDID. Everybody in the chain has to speak the same language. Now, the repair tools do not fix that.
No, and actually, well, because it can't. Because
can't.
It literally doesn't have the translation that's necessary for that in order to speak that same language.
However,
Right.
the repair tool can assist in that, and here's how.
Okay.
If you have any modern device that has 4K HDR capabilities, it will typically have two HDMI chipsets in it.
Right.
A 1.4 chipset and a 2.0 chipset. Now, when you're going EDID and video, and it's mostly EDID, from non-HDR content to HDR content, that step up from a 1.4 to a 2.0 chipset happens quite readily, easily, and happily. However, once it gets to that chipset,
Yep.
and that data's done,
Yep.
it doesn't like to step back. It does not want to relinquish
There you go.
the
That's the big word of the day.
command of the system. So how do you reset that command, Adam?
Well, you unplug the HDMI cable and you plug it back in.
Typically, that's what you do. However, that's not an acceptable answer on the job site.
I don't have one back here. I know you're looking for it. I don't know where. I think somebody absconded with it for another project. So yes, the AIO2 with what you're
Has
looking for.
the hot plug interrupt built into it.
Yes.
Now, the AIO2 all-in-one, that was our sponsor for today, does a number of things for you. The first thing that the AIO2 does for you is it strips this capacitive loading. So we no longer have this time issue. We are in a proper, typically 275 to 350 nanosecond rise time. The next thing it does is, as episode 1 we discussed,
Yep.
it provides proper voltage and current for the 5-volt in the hot plug.
Yep.
It also, as discussed last week, fixes some issues with the kaleidoscope. Not that there's anything wrong with the kaleidoscope, because there isn't.
And again,
It
in
just-
fact,
It comes back to
there-
HDMI saying C. Phillips.
yes, and they're again. I love the Kaleidoscope because honestly, it's a very high quality system. In fact, what they're trying to do is they're
Make it
actually
better.
trying to make everybody else come up to that standard
And
of,
good luck
of
to them.
correctness, which as we can tell, and the reason for our product is to fix that issue is not
They
working
don't.
out very well. So,
But with the hot plug interrupt, meaning you just open the relay, stop hot plug, close the relay, reinitiate hot plug, the whole who are you, what are you, all the stuff that has to happen restarts, and it's correct. It's just like a sales. You know, when somebody walks in your door at your office or your shop or your store, you have to greet them. You have to find out who they are, what they want, find out what their needs are. Do you have the products to fill their needs? Once you determine all of this and you come up with an equitable price, you get their signature on a piece of paper and you deliver.
yep.
That is all EDID is.
Yep.
It's a sale.
Yep, it's that transaction,
Yep.
right? So when we're dealing with EDID and all the different things, one of the things that you talked about, of course, is that each link in the chain, or each link in the video chain that we have, and I keep going back to chain, but it's that stream.
The bus.
The bus. So when we go from our source device to the next thing in line, to the next thing in line, to the next thing in, all the way through to the very end, one of the things that we have to ensure, of course, is that everything along that chain does the same thing or has the same capabilities.
Or as close as possible, yes.
Right. So one of the things that we run into, of course, and you touched on a little bit, was the fact that as you get to the next device, if it doesn't have all of the information, so let's say we have an HDR, let's say we have, for instance, our Oppo Blu-ray player
Okay.
that we have over here, great Blu-ray player. If anybody from Oppo is watching these videos,
Please bring it back.
Please bring it back. As anybody who is watching the video has used them before, can attest to it. Fantastic devices. If you guys were losing money on it or something like that, bring it back, please. Everybody wants it. Anyways, let's say we have our Oppo Blu-ray player here, which is a true UHD HDR Blu-ray player. It can take a full, 18 gig UHD movie, and it can display it, or at least transmit it, right?
Yes.
Now we're going from there into a receiver of some kind, or an AVR of some kind.
Okay.
And then from there we're going to a television that has the capabilities of displaying a UHD 4K HDR
Yes.
display. So we'll go back to our favorite movie.
Billy Lynn's Long Halftime Walk.
Billy Lynn's Long Halftime Walk. Now in Billy Lynn's, of course, that is a 4K UHD HDR 60 frames per second. Now, it's not a 444, obviously, because there's not enough bandwidth for that, but it is a 420, which is, for most people watching it, it's pretty standard. So, anyways, all of that put together, as we're going through, the TV can display it.
Yes.
Okay? So let's say we run it through an older AVR.
It will not be able to support it.
Right.
And why is that?
Well, let's say it's a 1.4 AVR, something
Okay.
that only has HDMI 1.4. At that point, it literally doesn't have the physical chip.
And what is the bandwidth of 1.4?
It is 10.2.
10.2.
There you go. 10.2 gigabits per second. So that's the main reason why it's not going to work. Because
Well, it won't even recognize the HDR.
right.
It will not recognize the 60 frames per second because under the 1.4 rules, the best they had was 30.
Right.
You still could get 4K 30.
So in theory, what should happen is the AVR should respond and say, hey, I'm on HDMI 1.4, I have these capabilities. And then at that point, the source should, if it's been set to auto,
Adapt.
it should adapt to it. Now, it doesn't always do that, right?
No, it does not. And we're back to the hot plug trigger
Right.
on the AIO.
Right.
We run into a lot of issues like this where they have a 4K source, a 4K AVR, and a non-4K television. And because the source sees the AVR as a 4K device, and that's its primary negotiation, it's going into 4K HDR. The AVR is not downscaling, so it is not outputting video to the display. Or, even more common is a 4K source, a non-4K AVR, and a 4K TV. Because what's the first thing a source should look at? The display.
Right.
So it's 4K.
Yeah.
So let's kick ourselves into the 4K mode.
Yep.
And then the AVR can't do it.
Right.
In an application like that, your best bet is a matrix. And you and I have solved a lot of problems using the matrix in that format, where you can take the output of the AVR port and downscale it on some of the matrices
Right.
to the AVR,
Right.
and then send the raw unscaled version out to the display. and maintain proper EDID, because that can be adjusted on the outputs of the inputs of the matrix.
Okay, we have a question.
I have an answer.
You don't have an answer.
Oh,
I can almost guarantee you don't have an answer.
try me.
Okay. Quick question about the RTX 30 series. And I know what you're thinking right now. You're thinking Yamaha, but it's not. They're asking, can you run a 1440p 240 hertz on the RTX 3070? Now, what they're talking about is a computer graphics card.
Ah, then you're
Yes.
right. I have
So you have no clue.
You, however, probably do.
And actually, the only reason that I do is I looked it up real quick. So, and the truth of the matter is that it does have an HDMI 2.1 output on it. I don't know how many it has. I think it just has the one. So here's the deal. When it comes to computers are weird in their output, their video outputs. So 240 hertz at 1440p. In theory, the HDMI output of that should be able to do the 240 hertz. In theory. Now, of course, you need a display that's actually going to be able to handle 240 hertz, which most of the normal TVs that you can buy out in the market don't go up to 240 hertz. Instead, you're going to be looking at an actual computer monitor or gaming monitor that can actually support that. Now, there's a couple out there. If you look at, I think, LG and Samsung, both have displays that can go up to 240 or higher. However, they're not. You're not going to be going over an HDMI connection. You're going to be using a display port. So, in theory, yes, the HDMI port could go that high. Are you going to find a display that can handle 240 hertz? Probably not yet.
Now, you also should see VBR built into that, which is variable bitrate.
Yes.
That is part of the HDMI 2.1 spec. And VBR, variable bitrate, is awesome, and here's why. Let's say you're gaming and you got a fairly static screen like this.
Mm-hmm.
There's nothing going on here, so we can actually drop the refresh rate down dramatically and take a load off the system. Your card runs cooler, the system runs cooler, quieter. But then suddenly somebody comes running across, you got all kinds of action that's now turned on. The bit rate will adjust so that you don't get any slurring of the video. Now, the whole system has to be set up to do this.
Yeah, which all pieces of that, again,
which
the
takes
output
you
and
right
input.
out of any AVR.
Yes, and with all of that in mind, again, FlameRunner64, thank you for the question. That was a really great question. I'm really glad I had an answer for that too. But yes, yeah, on games, computer games and whatnot, if you're using like the new RTX 3070 series, which just got announced like a week and a half ago, by the way. That's probably why that question came in. But yeah, on something like Counter-Strike, Global Offensive, what you've talked about in here, it can go. In fact, I think they have an unlimited frame rate on that, to where if as new stuff comes out, the frame rate just continues to go
Now,
up.
the thing to remember, and we'll put up a chart, it's not, and we'll have him post it afterwards. When you look at resolution, frame rate, and color depth, they have to adjust within a fixed parameter.
Right.
So let's say you have a TV that is capable of 240, but it may not be fully capable of doing 444 at 240, and I doubt that it is.
Right.
Or even 12-bit, because computers can do 12-bit on the video.
Yep.
So you may have to drop the 420 10-bit to get that 240.
Right. So actually, that's kind of a good point. How is it that the computer monitors can handle what seemingly is higher bandwidth requirements for higher refresh rates, even at a 1080p, that's a resolution, or a 1440p resolution? We're talking right now, it's very easy to get 120 hertz or 200 hertz or 144 hertz refresh rate on those monitors.
Well, it's a real simple question. What do you pay for a 32-inch 4K high-res monitor?
Right. You're probably going to be looking at a lot of money.
The same price that you're paying for a 70-inch 4K HDR. And what you're paying for is not the screen. What you're paying for is the processing inside of that monitor.
Right.
And to do as the screens get larger, circuits, the circuit board, the data transmission, all that impacts board design. So your cost to do a 70-inch gaming panel with that fast of a refresh on the pixels, that tight of a pitch rate on the pixels, would be substantially higher than would be commercially justifiable to a manufacturer.
Right.
That's why you see 32 is a big gaming screen.
Yeah. So when you're looking at, there's actually a really great chart online. If you do a search for HDMI bandwidth chart, it'll actually talk about, it's not exact. It gives you a really kind of
It doesn't cover HDR.
Yeah, it doesn't cover HDR.
Or HLG, or Dolby Vision.
And what I'll do is I'll actually make sure to put a link to the actual article
Chart.
that it's from for that chart. Because the chart's great. It actually, we use it here in the lab when we just need a really quick, look at how much bandwidth we have to deal with at a certain frame rate or certain whatever. So at the resolution that you're talking about,
Can you
actually
pass that to the screen?
bypasses it. I can't.
So
no,
he wanted
no, I can't.
1440 at 240.
1440 at 240. Now I don't have that on this chart because I only have the regular consumer grade, consumer
Not the
electronics,
PCs.
the CE, not the
Yeah,
PC stuff.
there's like 180 different options under 2.1.
So at 1080p, 60 frames per second, 444, 12-bit, we are at only 4.45 gigabits per second. Now the HDMI 1.4 specification can go up to 10.2. So in a 1080p resolution at a high frame rate, you're actually going to be increasing that again because in 1080p you actually have the capability of doing 120 hertz.
It was there,
at
but it
the
was never
1.4.
used.
Not really. And in fact, Sony used it once for their PlayStation 3. You could do a 3D using 3D glasses. You could have one person see one screen, another
Right.
person see a different screen on a 3D TV. And so that required, in order to play at 60 frames per second, that required 120 frames per second so that each person had 60 frames per second. Kind of a really cool design, but what they did is at 120 frames per second, we're doubling the amount of bandwidth. So you can think 4.45, we're doubling that. We're now going up to 8.9.
It's basically 9.
Yeah, basically 9.
Because you still have
gigs
overhead
required.
and commands and everything else.
And audio and whatever
Right.
else with it. So when you jump up to 4K, now this is just 4K 30, and we'll go ahead and do 12-bit. We'll keep it at the same
For gaming.
For that. We're now jump up to 13.37 gigabits per second, which is beyond the 10.2. So kind of split the difference between that because 1440 is and 1080p. That's basically the
Well, no.
between.
When you
that.
look at 1440, that's not. Remember, it's 1080p by 1920.
Correct.
So 1440
Yeah.
is going to be, that's the low number,
Yeah.
not the high number.
Correct. So you're well, yeah. So at that point, you need to cut it in fours or a third, basically, to cut down to that. So you're going to be in a bandwidth of about 10.2 at 60 frames per second for 1440.
I think it's like 2200.
Yeah, something
1440
like
by 2200.
yeah. So you're going to be at 60 frames per second at 1440. You're probably right at the 10.2 gigabit bandwidth requirement. So as you jump up from there, if you got to think to get to 240 hertz, you are jumping up 4 times that. So we're getting up into, again, 48 gigs at HDMI 2.1. So again, in theory, yes, it would work. In theory.
Find a good, you're going to have it's got to be 2.1 chipsets and everything.
Yep.
The computer and the panel. And the thing about 2.1 is the chipsets is kind of a guideline. You're not going to get 240 refresh on AVRs yet. That's next year.
Right.
If.
Yeah. And hopefully we do, because honestly, a better picture would be a 4K resolution
Oh, yeah,
with
well,
a higher refresh rate and a higher
yes.
bit rate.
Now, see, here's the thing. I would much rather see 4K at 120 or 240 versus 8K at anything.
Yeah. Well, and I mean,
And
honestly,
what I'd really rather see is 444.
which we're going to talk about this, not in next week's episode, but the episode after that, when we talk about TMDS. Because that's where we get into talking about bandwidth and bandwidth requirements and what it's going to take to actually get up to these higher
Yeah, which
resolutions.
is not EDID, but
No, but again, thank you for the question. That was a really great question. As always, everybody else who's watching and chiming in, thank you again for watching. If you have questions like that, or if it has nothing to do with what we're talking about, please put it down in the chat section below. We're happy to nerd out and talk about that stuff
and
as
if
well.
we get any of it wrong, be like the guy 2 weeks ago. Call us out.
Yeah, please do. Yeah, we love, honestly, I love hearing that I'm wrong.
Yeah, because we learn.
Yeah, exactly. So with that said, Brent, I think we did a really good job of covering EDID.
What's next week?
Next week we are going to be talking about CEC and a couple other features on that same channel.
Can we just turn that episode off now?
Well, pretty much. Yeah, that's pretty much what we have to do, right?
So basically, hi, I'm Brent. I'm Adam.
Turn off
CEC.
CEC.
Turn it off.
Yep. Bye. See you next time. So no, honestly, check in next week. We're going to be talking about CEC.
And by the way, there's some things that do require it.
Yes, there is. We'll be talking about CEC and a couple of the features that we have on the on the same channels that CEC uses.
And EDID's moving there for 2.1.
Yes, it is, and including something that's not used by anything that I can think of. Yeah, but we'll talk about it and talk about how it would work. Right? Okay.
More importantly, why?
Yes. So, Brent, we had a call.
Okay.
You alluded to it earlier. We had a gentleman call in who had he had two devices. He had a Roku Ultimate. And he also had a
cable
box, which was, I believe, an Xfinity. And it was a 4K Xfinity.
Which caught me by surprise because I had not seen that yet.
Yes. Now, he was going from those two devices into a Sony 1100 ES series receiver. From there, he was going into an extender, and then from the extender, he was going to a Sony 295. 295, thank you, yeah.
Which, by the way, speaking of news real quick, should be back in stock in the U.S. this week.
Have you been talking to our contact over at Sony?
So they should be back on allocation. So if you have one ordered on your dealer, you may be hearing from him this week.
Great. So in his problem that he had, the Roku was working. The Xfinity was not. He would switch back and forth between the two of them, and then he would go up to the display. Now, what was interesting is that he put in our AIO2 after the AVR, and he's a Control 4 dealer, so he used the contact closure through Control 4. Yep, yeah, he did. He watched our the video. Oh, that's yeah.
Finish your story first.
Yeah, we'll get back to that. So yes, anyways, so he put the AIO2 after the AVR. Now, that's a good spot for it.
Typically.
Yes.
Typically.
Now, he did that, and then all of a sudden, he was still not doing anything.
He got nothing.
He did the hot plug, and interrupt on it, and for a while the Roku worked fine, and then after a little bit of time, but the Xfinity did not work at any point. After a little bit of time, he would turn the room off and turn the room back on. If you're a Control 4 dealer, you know what I'm talking about. But then finally, it got to the point where he didn't have any video whatsoever.
Right. And and I went to lunch just as you were finishing this up.
Right.
We had him bypass the AVR.
Yep.
And go cable box to projector, and at that point he had no picture.
Yes.
I asked him to power the box down for 15 minutes, disconnect coax, power, and HDMI. And then?
He has not called back yet.
Oh, please call back.
Yeah. But our assumption at this point is that it's not going to work. Or at least that's my assumption anyways. So here's what's happening in my mind at this point. A couple things could be happening. First and foremost, we have an extender, and we're going to long distance. Which, whenever you're adding long distance to a situation, you add in the possibility of what we talked about today. Capacitive loading. Now, we also have a cable box connected to a coax connection, which goes outside of the house.
Which could be causing its own capacitive loading.
Which could be causing its own capacitive
loading.
Due
to grounding.
Exactly.
Which was 3 weeks ago.
Longer than that. It's been a while since we've had that episode. But, yes, in my mind at this point, if you're watching this episode, give us a call back either way. But I think we actually have a grounding issue with this. I think what's happening is that we're building up capacitance loading on some channel, whether it be the coax coming into the house or the line going from the AVR to the projector is long enough, or it's crimped in a certain way to where it's building up capacitance loading.
Here's the other thing, and we did not get a chance to get into this with him. I asked him what resolution he was on. Do you know why?
Fill me in.
Because that projector will not support 480i.
Okay.
See, 480i is part of the spec, but very few devices on the HDMI port properly support 480i.
Right.
So if he was on if the cable box was not set up to output a fixed resolution, say 1080i, 720, 1080p, whatever.
Yep.
And that was on a non-HD channel and it defaulted to 480i.
Yep.
That can cause everything downstream to fail.
Very much so. Yeah.
And by the way, we talk about this with EDID. When you are setting up your hardware, one resolution, never auto. Never auto. Pick a resolution. Whatever matches your TV the best, your display the best. If it's 720, 1080, if it's a 1080p, pick 1080i.
Yep.
If you've got a 4K option, take it. If you don't have 4K, pick the highest 1080.
Yep.
Now, if HDR is an option, say yes, enhanced. Now here's the thing. If you click a source on enhanced, your AVR has to be on enhanced. If your AVR is on enhanced, your display must be on enhanced. Because if it's not, you're going to have massive EDID failure and nothing's going to work consistently, if at all. Pick your audio. Dolby Digital has been the default. Atmos if you have it available. We don't see a lot of DTS anymore. Dolby Vision. Dolby Vision can be happy or not happy thing because there are different profiles of Dolby Vision.
Yeah, and usually whenever Dolby Vision comes into play, my first thing is to turn it off. If it works and it's working fine, leave it alone.
But if you get any glitches at all, they're going to get worse.
Turn that off. So everybody,
and CEC.
Honestly, we're going overtime here right now, so we need to go ahead and shorten this up just a little bit.
What was the question?
The experts is saying that we should do an episode on EDID on video switchers, like matrices and splitters and switchers and whatnot. That's a really good topic.
Yeah, because that takes me back to another question I got at tech support at lunch today.
Yeah, so we may have to talk about that at least after that question.
That's after the deconstruction.
Yes, we'll come back to that. But yes, very much so. It does have a lot of issues if it's not handled correctly,
and can fix some major issues.
Which actually one of the old Control 4 systems had a really interesting way of doing it. Their matrices, they actually...
That was the leaf piece?
Yeah, the leaf piece. Or no, it was the one before. It was a leaf piece, but it wasn't a leaf piece.
Right.
It was Control 4 piece. But they had it set up in a way that when you turn on all the sources and all the displays, and it would scan everything and retain that EDID information in the matrix.
That can be interesting too.
Yeah, that's kind of an interesting setup. But anyway, so... Yes, very good question for that. We'll definitely need to talk about that. Thank you for the video idea. We'll definitely put it in the lineup for that. So, everybody, as always, thank you for checking in with us today. If you have other questions or any comments or questions or anything else that you may have or concerns, leave it down in the comment section below if you've gotten this far and haven't asked it yet. We do check those and monitor the comment section throughout the week. Between episodes, and so we're happy to respond to that at that point. And in fact, if you leave a comment and a question, you may be in the next episode because our friend was last week.
Yes.
So at that point, thank you again for checking in with us, everybody.
If you're watching and you're not subscribed, please subscribe.
Yeah, hit that subscribe button, hit the bell notification, give us a like, let us know that we did a pretty good episode today. If we've helped out in any way for you.
And honestly, if you call with a tech support question and you call because of the video,
yeah,
say, hey, I watched your video, I have a question.
Yeah.
It is nice to know that we do have an impact.
Yeah. Check in with us next week. We're going to be talking about CEC and the other stuff that happens on that same channel on the HDMI cable as well. And we will talk to you then. As always, everybody, you can contact me on our tech support team at 386-492-8584. You can call Brent at 866-839-9187 extension.
And we'll track me down, 2203.
2203, and it will track him down. And so with that, everybody, thanks for checking in.
Wait. Reboot early.
Reboot often.
Don't cut your wires too short.
Turn off CEC and call tech support.
I'm Brent.
I'm Adam.
Have a great day.
We'll see y'all next time.